morning students, my name is Priyanka Jain. Our second chapter, electrostatic potential and capacitance. What is electric potential? Electric potential at any point in an electric field is equal to the ratio of the work done in bringing a positive charge, test charge, from infinity to that point to the value of test charge. Now, what is electric potential? In this, we have discussed about what is potential energy and what is electric potential. So, the work done in bringing a charge from infinity to that point, if we consider some charge present here, to bring a charge from infinity to that point, some force is applied, that is electrostatic force that has been applied, and in bringing a charge, some external force will be applied. So the repulsive force act between this or electrostatic force, that is F external, will be equal to F E. Now some charge present here will be Q0. So in bringing a charge from infinity to point A, the potential will be VA, and in bringing a charge that is from infinity to A, the potential difference will be equals to the work done in bringing a charge from infinity to A will be equals to W infinity to A upon per unit charge or present, or the value of charge present on that test charge. Now, the potential in infinity will be equals to 0, then VA is equals to W infinity to A upon Q0. This is our electric potential. When the work done in bringing a charge from infinity to A and the charge present in that. Now, what is SI unit? We know that the potential is measured in volt. So, if we consider 1 volt, then work is measured in joule. So, 1 joule, and charge is measured in coulomb. So, 1 coulomb. 1 volt is equals to 1 joule per coulomb, or 1 volt is equals to 1 joule per coulomb. This is the SI unit of potential or electric potential. Now, to represent in dimensional formula, we know that joule is equals to Newton into meter upon ampere per second. Ampere into second. Now, Newton we can write kg meter per second square, and meter will be m, ampere will be a, and s. With this we can write kg meter square upon ampere per cube, that will be 3. Now, to represent in form of m, l, t, a. So, meter will be 2, meter will be a, length will be 2, time will be 3, ampere will be 1. ml square t minus 3 or a minus 1, that is the dimensional formula for electric potential. Okay? Our next topic is electric potential or potential difference between two points. electric potential difference. Now, if we consider a point O from here to here, this is our point. Now, from A is a point and there is a point B. Now, to bring a charge from A to B, some force will be applied and intensity will be this side. The charge or the force applied to it will be Q into E. To bring a charge from A to B, the distance will be considered, or the displacement is dr. So, what is potential difference? The potential difference between 2 points in an electric field is equals to the work done in moving a test charge from one point to other to that value. Now the potential difference in this, the potential difference will be VA, and in this the potential difference will be VB. So VB minus VA will be equals to work done in bringing a charge from one point to another in per unit charge. This is our potential difference in bringing a charge from one place to another, and its SI unit is volt is equals to joule per coulomb, and its dimensional formula is ml square T minus 3 A minus 1. This is the dimensional formula for potential difference. Now our next topic is electric potential at a point due to a point charge. Now if we consider a point O here and point A is here, to bring a charge closer to this point B, the displacement will be considered as dr, and the force acting between this will be equals to F is equals to Q0 E, and the intensity will be in this direction. Okay? Now, to bring a charge from A to B or from infinity to that point, that is the displacement between this, the force acting between this is also an external force. We have to put some external force, then only the charge will be, or the displacement will be dr. Now, there will be a point charge Q at point O. Now, here we know that a positive charge repel each other. So, there will be a repulsive force acting between point O and B. So, F will be equals to Q0 E. Now, some work will be done in this, and there is a small work, that is a small distance or displacement. So, we can say that dW is equals to F into dr, force into displacement, and the angle between an electric field and the displacement will be 180 degree. Then dW is equals to F into dr cos 180 degree, and therefore cos 180 degree will be minus 1. Then dW is equals to minus of F dr, and in place of F we can write Q0 E. Then Q0 E into dr. Now, if we bring a charge from infinity to that point, then the work done in bringing a charge from distance r, this is our distance r from O to B. this will be equals to minus of infinity to r q0 e into dr. Electric field due to a charge flow at distance r will be, then the intensity will be equals to 1 upon 4 pi epsilon 0 into q upon r square. Now the work done in bringing a charge from infinity to r will be equals to 1 upon 4 pi epsilon 0 into q0 upon r square into dr. Okay. Now what we have done, we are considering a point A here where some repulsive force is also at between, because there is a present of positive q charge. Now the distance we consider from A to B will be dr and from O to B will be r. Now force is equals to q0e, because there will be some positive charge with intensity E. Now there will be a small work done in bringing a charge from A to B will be F into dr. dW is equals to F into dr, and the angle between intensity and the displacement will be 180 degree. So cos 180 degree will be minus 1, then dW is equals to minus F dr. Now dW is equals to minus q0 e dr. Work done in bringing a charge from infinity to distance r. This is our distance r. So by putting the value from infinity to r, q0 e dr. Now the intensity will be 1 upon 4 pi epsilon 0 into q upon r square. Work done in bringing a charge from infinity to r will be equals to, in place of e we will put 1 upon 4 pi epsilon 0 q into r square into q0 upon dr. Now work done in bringing a charge infinity to r, that is equals to minus of infinity to r 1 upon 4 pi epsilon 0 into q upon q0 upon r square dr. Constant term we will take outside, then infinity to r will be equals to minus of 1 upon 4 pi epsilon 0 into q into q0 infinity to r 1 upon r square dr. Now work done in infinity to r will be equals to minus of 1 upon 4 pi epsilon 0 q into q0. This will be equals to 1 minus r upon infinity to r. Work done from infinity to r will be equals to 1 upon 4 pi epsilon 0 into q0 upon r square. Now the potential difference at A will be VA is equals to work done in bringing a charge infinity to A upon q0, then VA is equals to 1 upon 4 pi epsilon 0 into q upon r into q upon r. This is our r. Now if there will be a medium of dielectric constant K around the charge Q, VA is equals to 1 upon 4 pi epsilon 0 into Q upon K into R. If there is a dielectric constant K around the charge Q. This is our final potential, electric potential due to a point charge. Okay. Now, if there is a system of charges, if there is a system of charges, this is our second topic. charge. Then potential will be equals to 1 upon 4 pi epsilon 0 into positive Q1 upon R1 plus Q2 upon R2 plus Q3 upon R3 and so on volt. Then the potential will be equals to 1 upon 4 pi epsilon 0 Q1 upon R1 minus Q2 upon R2 plus Q3 upon R3 minus Q4 upon R4 and so on. This will be equals to, in general form, potential is equals to 1 upon 4 pi epsilon 0. We are taking summation where the limit from 1 to I is equals to 1 to n Qi upon Ri. This is the system of charge. Now we will continue